So now this video actually discusses about what equate as the angles, where I'll be talking about what is an angle, the measurements of the angles and also the types of angles. So in this case, what is an angle? Let's say we have, this is a straight line. Let's say we have the straight line, and we have another straight line emanating from the same point. Let's say this is the point A, like that. And let's say this is I should equate as B, and this is C. Now let's say this is an arc between the two lines, like that. Now if we say an angle, it is an arc formed whenever two lines actually meet. That's what we call as an angle. So it has an arc formed at the point in which the two straight lines actually meet. That's what we call as an angle, and it basically can be symbolized as theta. So you be coming across the symbol for angle being given as theta, it is okay. And basically another angle formed, it is also this angle as well. So this is another angle as well formed. So this is also another angle. So like that. And let's go, this is angle theta, should be angle theta 1, and then this is an angle theta 2, like that. So if you say an angle, that is an arc formed at the point in which the two straight lines actually meet. That's what we call as an angle. And let's say we can have, the angle theta can also be specified as, angle, CAB, angle CAB. That is how we can call it. That is the angle theta 1. And we can also specify actually as many as possible. Let's say if we can have this as that, let's say we can have, let's say, this as that. So the angle formed, let's say this is an angle. Let's say this is A, we have B, and this is C. And what is the angle formed? It is given as the angle ABC. So which means the letter at the center represents where the angle has been formed. So keep that in mind. And how about, let's say, if we can have this? Let's say if we have something about, let's say, like this. Let's say this is the case, and let's say we have, this is X, Y, let's say this is Z. Let's say this is an angle for interest. Let's say that is the angle. So that angle can be given as angle X, Y, Z. And even if you can wish, you can move from here up to this point. So which means you can call it as angle Z, Y should be X. It is the same, much as the letter at the center represents where the angle has been formed. So here is the task for you. Try to come up with any sort of the angle that you can draw that represents the following. You just have to try to present the following angles. Let's say you should have to present the angle, let's say angle A, B, C. And also present the angle, let's say angle X, Y, Z. And also present the angle, let's say angle 1, let's say angle 1, 2, 3. And let's say we should have to present the angle, let's say should be Q, R, S. And also present the angle which is given as M and P. And also present the angle which is given as X, Y, Z. So should be OPQ. Should be the angle OPQ. So try to present those angles just to be, just have to present them in whichever the orientation, but the straight lines has to meet somewhere and show what is that angle of interest. Now, the angles actually can be measured in what you call as the degrees, and also they can be measured in radians as well. So can be measured in radians, and it can also be measured in revolutions. So let's see how we can have to specify. So by the way, in degrees, let's see how we can be able to express the angles being measured in degrees, radians, as well as the revolution as well. Let's say we have the circle. No, let's say this is the circle like this. Let's say that is the case. Let me just have to present it in this case. Although I'm poor in drawing, but I will try my level best that whatever I'll be presenting here should basically make sense before you. And let's say this is the circle like this. Anyways, let's say that is the circle, and this is the center of the circle, like that. And let's say this is the reference line. Let's say that is the reference line, and let's say the center is given as should be O. And let's say this is A. And now let's say this is, let's say we have, this is point B along the circumference of the circle. I'll call it as the point B. Let's say this is a point B. Should be this is the point B. And let's say the circle is of radius r, like that. And let's consider, let's say, having the straight line OB, like that. This should be like that. And in this case, from A to B, the distance along the actual circumference of the circle, it is given as the arc length, which is given as S. So this is the arc length. That's the distance from A to B. That is said to be the arc length. This particular distance, that is said to be the arc length, like that. And from A to B, of course, this is the arc length, but there is also an angle formed at the center. I'll call it as angle theta. So which means moving from point A to point B, the distance covered along the circle is given as arc length, which is given as S. And the angle formed at the center, it is given as theta, like that. So we should have to understand that the angle formed at the center is equal to the arc length divided by the radius of the circle. This is how we can have the angle formed at the center, which is the arc length divided by the radius of the circle. But now let's assume that the object, or I should say, let's assume that the object, or we should have to say, let's assume that the object has traveled from point A all over up to back to the same point A. If that is the case, then we say the object has traveled along the whole circle. If we are to move, or if an object is to move from point A and back to the same point all over for the whole entire circle, then the object is said to move, then the object is said to cover the whole actual circle. If that is the case, then what will be the arc length? Now arc length, if the object completed the whole circle, it is given as 2 pi r, which is the circumference of the circle. So in this case, the angle swept at the center, or angle formed at the center, will be given as 2 pi r divided by r, of which this and this r will be cancelled. That will be given as actually the angle at the center will be given as 2 pi. Now what we have is the angle being measured in radians. That is, angle at the center will be given as 2 pi rad. So the angle measured in radians, it is being given, the SI unit being given as rad. So which means you can have, let's say, 60 rad, that is possible. We can have, let's say, 70 rad, that is possible. We can also have, let's say, 2 rad, that is possible. So that's how we can also have to measure the angles in terms of the radian measures. So keep that in mind. So which means the angles can be measured in radian measures, as we have specified that and as about. So take note of that, where pi represents actually 22 over 7, which is the same as 3.14. Of course, you should have to know the value of the pi as it stands there. So now we have seen that a one complete cycle represents actually represents 2 pi rad. Now you should have to understand that on the same case, you should have to get it that, you know, angle swept at the center, if the object completed the full cycle, will be given as 2 pi rad. Now the same, since it has completed the full cycle, then the angle formed by the cycle, it is given as 360 degrees. Then we say the object has traveled about 360 degrees. So which means we have 2 pi rad is the same as 360 actually degrees, of which 2 divided by 2, we have it as pi rad is equal to 180 degrees. So which means the another way in which we can be able to measure the angles, it's by using degrees, which is symbolized as, should be with the symbol which is the power given as naught, like that. So which means we can have, let's say, 25 should be degrees. We can have, let's say, 7 degrees. We can have, let's say, 60 degrees, and sort of. So this one has also gave us the conversion factor that we can use to, you know, change from, let's say, a rad to actually a degrees. That is. And also you should have to understand that if the object has completed the full cycle, I should say, if the object has completed the full cycle, then we should have to say that the angle swept at the center is given as 2 pi rad, and which is also the same as 360 degrees as we have seen it. And also it is said to be actually traveled about 1 revolution. So if the object has completed 1 cycle, then we say that is 1 revolution. So which means 360 degrees, it is the same as the 1 revolution, that is symbolized as rev. And also 2 pi rad, it is the same as 1 revolution. Now here is the summary of everything. Here is the summary of everything. We should have to understand that 2 pi rad, it is the same as 360 degrees, it is the same as 1 rev. That is. And let's see the conversion factor between the actual rads, radian measure versus degree. So we have already specified that, you know, 2 pi rad is equal to 360 degrees, you know, which is the same as 1 pi rad, it is the same as 180 degrees. So this is what we use to convert the angles from radians to degrees. And radian versus revolution. So 2 pi rad is the same as 1 rev. So this is the conversion factor that we use to change from radians to revolution, and likewise. And also we should have to get that should be degrees, should be versus left. If that is the case, we understand that 360 degrees is equal to 1 left. We should have to get that one. So otherwise, if we are to convert from left to degrees, it's possible like that. Now let us see how we can change the following. Convert the following given actually angles into degree measures. Let's say if we have 25 flat. So how do you think you can have this in degree measures? So in this case, we are to move from right to degrees. How do you think we should have this? Now the relationship says that pi right, it is the same as 360. Should be it is the same as 180 degrees. Should be it is the same as 180 degrees. So using this case, it means we'll have now been given us. How about if we have 25 flat? How do you think you can have that? So 25 flat will be actually more. So in this case, we'll have it as 25 right divided by pi right times 180 degrees. So right and right will cancel, where I'll have it as 25 times 180 should be 25 should be times 180. That is 4,500 divided by pi, of which pi it is given as. So what is the value of the pi? That is given as should be 4,500 divided by 22 over 7, and that will be given as 25. 4,500 times 7 over 22, and which is that will be given as should be about that is about being given as 1,000. Should be 1.8. That should be degrees. So that's how it will be. That is to the 1 decimal place. How about let's say if we have 30 pi right. How do you think you can have this in degrees? So in this case, principle remains the same. We should have to understand that a pi rad, which is 1 pi rad, it is the same as 180 degrees. How about the 30 pi rad? So in this case, we'll have it as more. So have it as 30 pi rad divided by 1 pi rad, and the times 180 degrees. So this pi and this pi will cancel. That will be given as should be 30 times 180. That is 30 times 180. That is given as 5,400 degrees, like that. And how about let's say if we have this, let's say if we have 60 left, how should you have this in actually degrees? So we should have to understand that 1 left is the same as 360 degrees. How about 60 left? We'll have it as more. If that is the case, we'll have 60 left divided by 1 left, which is times 360 degrees. that will be given as 60 times 360. That will be given as 21,600 should be degrees, like that. And I convert the following actually angles into radians. Let's say if we have 200 degrees, we should have it in radians. So if that is the case, we need to understand that 180 degrees is the same as pi rad. How about the 200 degrees? It will be exactly more. So in this case, we'll have 200 divided by 180 degrees and the times pi rad. So in this case, we'll have 200. So in this case, this is the same as actually this cell and this cell cancel. We'll have it as 20 pi divided by 18. Of course, we can have to express and simplify much this. 2 into should be 8, actually 20, that is 10, into 18, that is should be 9. This is the same as 10 pi divided by 9, or else we can just have to substitute with the value of pi, which is 22/7, which is 3.14. 3.14, rather, have it as 10 times 3.14 divided by 9. You can have it should be in rad. And how about, let's say, if we have something like this? Let's say if we can have should be, let's say, 60 degrees. How should you have it? And let's say if we have should be, let's say, 90 pi, should be 90 left. How should you have this in radians? So try to express that, and also try to have the following angles in that to be in a degree measure. Let's say if we have 1/2 left, and let's say if we have 1/5 left, we should have in degree measure. And let's say if we can have 4/5 rad, we should have in degree measure. And let's say if we can have should be 6/7, we should also have in degree measure as well. So should be that. Now let's extend our discussions by looking at the types of angles. So the angles are classified based on their measurements. I should say based on the values of the angle that are being measured. So we have the first type, which is said to be the acute angles. So acute angle, it is the angle which is less than 0 degrees. It is the angle which is less than 90 degrees. So these are the angles that ranges from 0 to 90 degrees. In other words, they are actually within 0 and 90 degrees. We can have them, let's say, 60 degrees. This is part of the acute angles. 25 degrees, that is part of the acute angle. Let's say 75, 89, but not 90. Let's say 89.67, that is an acute angle. We can have, let's say, 27. So any angle that is within 0 to 90, that is part of the acute angle. And how should we have to depict it on the on a typical diagram? So let's say this is actually a Cartesian plane. Let's say this is a Cartesian plane, like that. So in this case, you should have to understand that this is x and this is y. Of course, this one is not necessarily much about, but anyway, let me just have to this. Let's say that is the case. Now whenever we are drawing or presenting an angle, we need to start from this actually a vertical line. So in this case, you know, the arched angle, it is an angle that is within this space. That is an arched angle. It is an angle that can be drawn within this space, or it is an angle that can be drawn within this space, or that can be drawn within this space, or that can be drawn within this space. So that is, let's say we have an example of arched angle given as 30. So in this case, this is, let's say, this is the reference actually a line. Now the angle is measured using the protractor. You present your protractor and center it here, then you start counting up to, you know, reaching at 30. So in this case, this is an angle of 30 degrees. So in this case, this is an angle of 30 degrees. That is an arched angle. That is being measured from the reference line and to this particular direction. And we also have another type of the angle, which is said to be the right angle. So what do you think is the right angle? Right angle, it is the angle of 90 degrees. It is exactly angle which is 90 degrees. That is said to be the right angle. And basically it is just symbolized as this. So this is what we call it as the right angle. So it is given as that. So this is the symbol for the right angle, which is 90 degrees. It's either you can label it as 90 degrees upon presenting it this way, or you can just have to leave it that way. So wherever you see this kind of angle being presented as that, it means it is right angle. So keep that in mind. And we also have the angle which is said to be the obtuse angle. We call it as an obtuse angle. So what is an obtuse angle? So obtuse angle, these are the angles that ranges, these are the angles within 90 to 180 degrees. We call them as obtuse angles. These are the angles that ranges from 90 degrees to 180 degrees. That is obtuse angles. So we can have, let's say, 180 degrees, that is 150, 170, 170, let's say 9, let's say 160. All these are the examples of the obtuse angles, like that. And we have also another example, actually be a type of the angle that is said to be the reflex angle. So reflex angle should be the reflex angle. So reflex angle, that is the angle within 180 to 360. So that is what we call as the reflex angle. So this is the angle which is greater than 180 but less than 360. That is a reflex angle. We can have, let's say, 250, 270 degrees. We can have, let's say, 210 degrees. All these are the examples of the reflex angles you can have. So what is the point of reference? And whenever we are drawing the angles, so whenever we are drawing the angles, the point of reference, it is the actual circle. And basically the angle of a circle, it is given as 360 degrees. That is the angle of a circle. So which means, let's say we should have to present the Cartesian plane as I presented it before. Let's say we have that and as that, and also we have this as this. let me just have to call this one as a cardinal point. So actually a cardinal points can be that. Let's say this is the North Pole in that. So from, let's say, a North Pole, and now we can measure the angles from, this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is 360 degrees, like that. So which means, let's say if we are to come up with an angle, let's say 60, so 160 will be within this. So how should you have it? So in this case, with protractor, the angle will be measured from the North Pole, can be somewhere here. So this is an angle of 160 degrees. How about the angle of, let's say, 60 degrees? So the angle of 60 degrees, it is the angle within this, that we can have really from the North Pole, can be given as somewhere here. So this is an angle of 60 degrees, like that. And how about, let's say, the angle of 190 degrees? So the angle of 190 degrees, it has to be something somewhere here. So this can be the angle of 190 degrees, like that. So that is 190 degrees. How about, let's say, the angle of 210 degrees? 210 should be somewhere from here, up to this point. That is, you can have 210 degrees. It can be also approximating the same, but whenever you are drawing that one with a protracted, it becomes more accurate. And how about the angle of, let's say, 300 degrees? So the angle of 300 degrees has to be somewhere here. So being measured from the North Pole like this. So this is the angle of 310 degrees. And how about the angle of, let's say, 320 degrees? So 320 can just be somewhere here, measure from this point. That is how we can have it. So by now you know what is the angle, types of angles, and also the measurements of the angles. Now with your protractor, try to draw the following angles. Let's say we have 260 degrees, and we should have 110 degrees. Let's say 320 degrees, and we should have, let's say, 259 degrees, and let's say we should have 102 degrees, and we should have, let's say, 170 degrees. And also you should have the following. You should have to mention 5 examples of acute angles, and I just have to draw them. Examples of acute angles, and draw them. You should also have the 5 examples of reflex angles, and I just have to draw them with the protractor, and also 5 examples of obtuse angles, and also you should have to draw them as well. So I want to see the progress in the comment section below, if at all you are able to or not. So that's how you just have to get it in that way. Thank you.